Welcome to Gradeful, where we can start preparing you for the SAT or ACT today, anywhere in the world. Right now, we're going to look at SAT, College Board's SAT Practice Test 1, Section 3. So the best way to do this is to pause this video when you see each problem, try the question on your own, and then compare your answer to our answers. So question number 1 here is saying that it has this equation here, and k equals 3, so we'll fill that in as 3. Now you can solve by multiplying both sides by 3. That'll get rid of the 3 on the left and turn the right-hand side to 9. And add 1 to both sides, and x is 10 on this nice, easy first problem in the section. Going to number 2 now. We're adding 7 plus 3i and negative 8 plus 9i. And one important rule of thumb in general is to just treat I as x, unless you have something special like I squared or something like that. A lot of times you just treat it like an x and you can get to an answer. So let's try that here. We can combine like terms, 7 and negative 8, 7 minus 8 is negative 1, and 3i minus 9i is negative 6i. So I have negative 1 minus 6i. 7 minus 8. And why did I subtract it there? Because it's early in the morning, my time. It's 3i plus 9i. So 3 plus 9 is 12, silly. So we have 12i right here. And that's A for number 2. Going over to number 3. Okay, number 3, Armand sent M messages each hour for 5 hours. Tyrone sent P messages each hour for 4 hours, which represents the total number of messages sent by Armand and Tyrone on Saturday afternoon. This actually seems like your price times quantity statement, PQ. Now, of course, we're not talking about money, but price, more than being an amount of money, is like a number that goes along with each object. So for instance, if I have 15 sweaters and each sweater costs 20 bucks, then the price of the sweater is 20. But that's not any different than if I said I have 15 bags of fruit and each bag of fruit weighs 20 pounds. The math would be the same. It's still one number times the other, as we like to say, PQ. So here for Armand, there are M text messages for 5 hours, per hour for 5 hours. So 5 times M would be actually I'll write it as M times 5 to be more accurate, is the number of messages per hour. So we'll consider that the price, and the number of hours is like the quantity. And then we have Tyrone, which is P text messages for 4 hours. So his price is P and his number of times is 4. So we have 5M plus 4P. And the answer to number 3 will be C. Now, number 3 can also be taken actually from a unit conversion standpoint. So for instance, for Armand, if we have 5 hours and Armand sent M messages per hour, then in the unit conversion way of seeing this, some people call this dimensional analysis. I tend to call it chemistry style unit conversions. But this essentially, this blue thing here is equal to the number 1 in this way of thinking, because if there's M messages per hour, then for every 1 hour I get M messages, and this is nothing more than a fraction, with the same thing on the top and the bottom. So with this way of thinking about it, the hours cancels, leaving you with 5 M messages. And the unit remaining, like I said, is messages. And that's the same 5M that we got right here. And you could do the same thing for Tyrone. Tyrone did this for 4 hours. And there were P messages per hour. So the unit of hours cancels out right there, leaving you with 4P messages. which is what we had here. So you had the 4P and the 5M. So it matches up whether you look at it in terms of price and quantity or whether you look at it in terms of unit conversions. So let's go ahead and go to number 4 now. Kathy's a repair technician. She has phones. The number of phones she has left. So P is the number of phones left. And it's a Y equals MX plus B. So I'll write it like this, negative 23D plus 108. So one thing that's done on the SAT very frequently is the MX plus B is reversed to B plus MX because it just makes it a tiny bit more confusing when you do that. But in any case, this being a Y equals MX plus B, the M is negative 23, the B is 108. And in terms of a linear Y equals MX plus B equation, this means we start at 108. So the B is 108. And we're decreasing at the rate of negative 23 over 1. And the slope is your change in Y over change in X. So that's the change in number of phones for every change in D, and D is the number of days. So the change in phones per day is negative 23. The starting amount is 108. So what's the significance of the 108? It's the starting amount. And in a conversation about the number of phones left, that could be said to be the amount of phones that she has left before she's done any work, which is choice B right here for number 4. Now we're moving on to number 5. Okay, in number 5, the first thing that sticks out to me is this minus sign here. Definitely consider that like a -1. It'll kind of make you more apt to want to distribute it. So -1 times the green term is positive x squared y, and -1 times the blue term is negative 3xy squared, and -1 times the purple term is positive 3y squared. So just reviewing all of those, when you're multiplying positives and negatives, if you have the same sign, the answer comes out positive, and if you have opposite signs, the answer comes out negative. So in the first one, we had the same sign. In the second one, we had opposite signs. And in the third one, we had the same sign. So bring down everything we had before. X squared y minus 3y squared plus 5x y squared. Okay, and now we can combine like terms, and we can show these like terms with colors. So x squared y, these two have the fingerprint of x squared y. And y squared just by itself, that's these two. And xy squared, that's these two. So for the blue ones, we have x squared y plus x squared y. So just like saying one football plus another football gives me 2 footballs, 2x squared y's. And for the turquoise ones, we have -3 of the y squareds and +3 of the y squareds. So they cancel each other out. That's like saying I owe someone $3 and I made $3. So the two things put together means I have no money, which is just 0 right there. And then for the pink ones, we have 5 of the xy squareds and -3 of the xy squared. So essentially it's 5 minus 3. So it's 2 of the xy squareds. And that's for the pink one. So the answer here is 2x squared y plus 2xy squared, which is choice C for number 5. Going over to number 6. Okay, so we have the height in inches. We just have to really make sure that the unit's not changing in inches per year, per year. So now that we have that, we can see this as a y equals mx plus b. And the b is the 28.6. And the slope is the a. So what is the increase in inches of the height each year? Well, okay, so looking at this, we've got a starting amount of 28.6 and an increase of 3. right? So just a regular linear. And they're asking us, what's the increase per year? Well, increase per year, that's the language of slope, the increase each year. And if you need a little extra confirmation, you can translate slope, which we do frequently. Translating slope is the idea of saying to yourself, slope is change in y over change in x, and then putting in what the question is talking about. So that's the change in height for every one change in age. So, or change in year is a better way to say it, because that's how the question is saying it. So the change in height for change in years. And so what's the increase in inches per year? It proved to us right there that it's matching. Increase in height per year, or the way we said it, change in height per change in year. The point is that we've confirmed that the slope is what the question is talking about. And the answer to number 6 is A. Going over to number 7 now. 7 is the quintessential SAT problem, where something very simple is kind of made to look like something very challenging. So go ahead and enlarge this a little for viewers that don't have the best display in the world for being able to see these things. And what we're going to do here is replace the green piece here with the letter A, the blue piece. Here. The blue piece here with the letter B, and the pink piece here with the letter C. So the way we're going to write it is M equals AB over C times P. So this was our A, this was our B, this was our C. So what we're doing is taking these really complex expressions and boiling them down to something really simple. If that's the case, and the question is asking us to solve for P, then, well, what's happening to P the way it stands right now? P is being multiplied by AB over C. So to get it alone, you'd multiply by the opposite, C over AB, C over AB. So the answer on the left-hand side is CM over AB, and that is equal to our P, because here you have this canceling with this, and this canceling with this. So an important thing to note, because we're looking at the answer choices here, we've got M's throughout, and they're not in the numerator or denominator. So M is really the same as M over 1. So we can rewrite this as C over AB times M over 1. And like we said a moment ago, M is the same as M over 1. So it can be rewritten again as C over AB times M right there in the middle. And now it matches the answer choices. So looking through here, all we have to do now is just replace what we had in green, blue, and pink. So the C, we'll write it back in as 1 plus R over 1200 to the N minus 1. So that's replacing C where it was. The A is the green one, R over 1200. And the B is the blue one, 1 plus R over 1200 to the N. And don't forget that we have an M that was just kind of in the middle. So this is our new expression after we take out the simple little terms that we created and replace them with the complicated ones. You get an answer choice that looks exactly like choice B. Now we're going over to number 8. 8 is our nice classic corralling question. The idea is, how can we turn A over B into 4B over A? So the way to do that is to kind of say, well, what's the difference between what we have, A over B, and what we want, 4B over A? So one thing is that I've got B over A instead of A over B. So the answer is yes, you can, to people who are wondering if you can flip both sides of an equation. As long as you don't have different terms on one side, that would complicate things. But if I have just a single term here and a single term here, then I absolutely can flip both sides. And the reciprocal of 2 is 1 over 2. So now we have b over a. And what's the difference between what we, do this again. What's the difference between what we have, b over a, and what we want, 4b over a? The only difference is that there's a 4. So let's go ahead and just multiply both sides by 4. And now we'll have 4b over a equals 1 over 2 times 4 over 1, which is 4 over 2, or just the answer 2. So the answer for number 8 is C. Going over to number 9 now. What's the solution to the system? So just looking through, I'm kind of looking for shortcuts, like maybe I might have had like 3x and negative 3x, or 4y and negative 4y, something like that. And as we're doing that, we're kind of noticing that the x's and y's are actually not lined up. So let's fix that. 3x plus 4y equals negative 23, and negative x plus 2y equals negative 19. So now we've got the x's lined up with the x's, the y's lined up with the y's. And what we want is, like we mentioned earlier, something that's going to cancel nice and easily. So let's take this first equation and multiply it by 3. Negative 3x plus 6y equals 19 times 3, which is negative 57. And just bring down the first equation the way it already is. 3x plus 4y equals negative 23. Now, when we add straight down, the 3x's are going to cancel. So the 3x's will cancel. And so that crosses out, and we have 10y here equals negative 80. Divide by 10 on both sides. Y equals negative 8. So the only answer that has y equaling negative 8 is going to be choice B. So the answer for number 9 is B. Looking at number 10 now. This is saying that g of 4 equals 8. So they're kind of quizzing us on our understanding of f of x terminology. And our y is equal to f of x, or in this case, g of x. So in other words, this whole thing equals 8. So y is 8. And the thing that goes in the parentheses of an f of x expression is your x. So x is 4 at the same moment that y is 8. So we can plug that into the equation. We can say we have the whole thing, y equaling 8, when x is 4. So 8 equals 16a plus 24. Take away 24 from both sides. Negative 16 equals 16a. Divide by 16 on both sides. And a equals negative 1. So now that we know that a is negative 1, let's plug it back into the original. G of x equals negative 1 x squared plus 24. So the difference between x and y, which are variables, and a, which is a constant, is that once we find a, it'll always be the same answer for a. It won't change depending on different x and y values. So now that we have the expression, what's g of negative 4? That just means plug in x equals negative 4. And negative 1 times negative 4 squared, which is 16. Negative 1 times 16 is negative 16. And you'll have g of negative 4 equals 8. So the answer for number 10 is A. Now we're going to number 11 here. Okay, B and C are the price per pound of beef and chicken. What was the price per pound of beef when it was equal to the price per pound of chicken? So if B and C are the two prices and they're telling us the prices are equal, they're saying set the first equation equal to the second. So 2.35 plus 0.25x is equal to 1.75 plus 0.40x. Take away 0.25x from both sides, and you'll get 0.15x, and take away 1.75 from both sides, and you'll have, see, 2.35 minus 1.75, 0, 13, 6, and you'll have 60. I thought it was 60 in my head, but I didn't want to be too quick with it. Now we got 60 equals 0.15x. Let's go ahead and move this a little closer so it looks a little better there. Divide by 0.15 on both sides. And 0.60 divided by 0.15. You can do long division if you like, but the answer is 4. So x is now 4, which for a lot of people will make them feel like they got a wrong answer, but they're not asking for x. They're asking for the price per pound of beef. So what's the price per pound of beef? B when x is 4. So that's 2.35 plus 0.25 times 4, because x came out to 4. So 25 cents times 4 is $1. So this is 1.00. 2.35 plus 1.00 is 3.35. And the answer number 11 is D. Number 12, we have a line that passes through the origin and has a slope of 1/7. So if you pass through the origin, it means your y-intercept is 0 and your slope is 1/7. So we're being given the slope and the intercept of this line. So if it's a y equals mx plus b, we have y equals 1/7 x plus 0, or just y equals 1/7 x. So now verbally, this means literally that the y value is 1/7 of the x value. Be careful, because that looks a lot like this, right? 1 and 7. But a lot of these are designed to kind of subconsciously pull you into a wrong answer choice. For which of these is the y value a seventh of the x value? That's this right here, because 2 is 1/7 of 14. The y value is 1/7 of the x value for choice D on number 12. Moving along to number 13 now. 13 is a rational expression. And for rational expressions, what you're usually doing is multiplying by a factor of the number 1, by a multiple of the number 1. And I'll show you what that means. So essentially, the thing that makes this a little challenging in appearance is that you have x plus 2 and x plus 3 in the denominator. So you have expressions in the denominator, which is a little more work than if they weren't there. So let's go ahead and multiply the top and the bottom by the exact things that we don't want, x plus 2 and x plus 3. So when we do that, let's put a little parentheses here. So we're multiplying by the number 1. Even though it looks complicated, the number 1 is a fraction with the same thing on the top and the bottom. And that's what we have in red there, the same thing on the top and the bottom. So it's allowed. We're allowed to multiply by the number 1 because it doesn't change anything to do that. So in the numerator, we have x plus 2 times x plus 3. We'd be foiling that. So first times first is x squared. Outer times outer, 3 times x is 3x. Inner times inner, 2 times x is 2x. And last times last, 2 times 3 is 6. So the numerator is going to be x squared plus 5x plus 6. In the denominator, we have the x plus 2, x plus 3 being multiplied by this. And when you do that, it looks kind of like this. X plus 2 times x plus 3 over 1 being multiplied by 1 over x plus 2. So I could maybe show that off to the side. X plus 2, x plus 3 over 1 was multiplied by 1 over x plus 2. So when you multiply it together, it looks like what we have right here. And the x plus 2's are going to cancel, by the way, because you have 1 on the top, 1 on the bottom. And when you distribute, you have addition signs in the middle. So for instance, a times b plus c would equal ab plus ac, right? So this thing we're multiplying by will be separated by a plus sign from the next thing that we multiply by, which is multiplying it right here. So that'll give us x plus 2, x plus 3 over x plus 3. And now the x plus 3's are canceling out. So simplifying everything, we have x squared plus 5x plus 6 on the numerator and x plus 3 plus x plus 2 in the denominator. So the denominator becomes 2x plus 5. And that answer is choice B for number 13. Moving on to number 14 now. 3x minus y equals 12. Okay, so when you have an exponent problem, they're often made easier by finding the most prime bases that you can find. So the most prime bases we can find. So our bases for these exponents are 8 and 2. 2 is a prime number already, but 8 is the same as 2 to the third. So we can convert this to 2 to the third to the x over 2 to the y. Now, the numerator needs to follow this rule. A to the b, all multiplied to the c, is a to the bc. So we'll have 2 to the 3x over 2 to the y. Now, so the idea is that if we have a power and raise it to a power, we're multiplying. But if we have a power and we take a root of that, then it's the same a to the b, but instead of multiplying by c, we're dividing by c. Now, another important rule is a to the b times a to the c is a to the b plus c. So if you're multiplying with the same base, you can add the exponents. But the opposite of that rule is a to the b over a to the c is a to the b minus c. And that's the rule we need right now, because we need to be able to say that this is 2 to the 3x minus y. Because it's 2 to the 3x, 2 to the y, 2 to the 3x minus y, similar to a to the b over a to the c is a to the b minus c. So right here, what we have are our 4 main exponent rules that you want to be really familiar with. And in this question, coincidentally, they gave us 3x minus y is 12. So we can just go ahead and say that this is all 2 to the 12th, which is choice A. Going over to number 15 now. A little subtle thing about number 15 is that they said that this is true for all values of x. So when we set two functions equal to one another, that's one thing that we do in the case of an intersection. So they're saying that these two things are intersecting all the time for all values of x. That's the idea of having infinite solutions. So what does it mean? It means that if I were to graph the first one, this is not the true graph of it, but just for conversation's sake, if I were to graph the first one, it would look something like this, let's say, just guessing. And if I graph the second one, I would kind of notice that it's actually the same one, because they are intersecting for all values of x. So they're saying that they're the same line as each other. And that's really critical, because not the same line, but the same curve as each other. The reason why that's critical is that for some of these curves, the A, B, and C, the coefficient values of them, count as the addresses. And you cannot have two addresses. So they're saying that they intersect all the time, and they're going to have the same addresses as each other. Put that all together, and we have parallel structuring. If I expand out the left-hand side, the components of that need to be equal to what we have on the right-hand side. So let's go ahead and simplify the left-hand side. First times first. So first times first, that's ax times bx. So that's abx squared. Outer times outer of the FOIL is ax times 7. So that's 7ax. Inner times inner is 2 times bx. So that's just 2bx. And last times last, 7 times 2 is 14. So an instinct in parallel structuring that you really should develop is the idea of grouping things together according to the common x value. So for instance, we have ab times x squared. So I just put parentheses there. But I'm also going to factor out x. And in front of the x, we have 7a plus 2b. So what is it we're doing right there? We're saying that for these two terms, the common factor is x. And if we divide them both by x, then it leaves us with 7a plus 2b, and that is allowed. And then here we have 4. So this kind of sets us up to have our x squared coefficient of ab, our x coefficient of 7a plus 2b, and 4. And these are intersecting all the time. The solutions are all real numbers. So in other words, every component of the other equation has to perfectly match it. So 15x squared plus cx plus 14, not 4, just copied it wrong there. Should have been 14 in that C spot all along. And so we've got AB has to equal 15, 7A plus 2B has to equal C, and of course, 14 equals 14. And that's the idea of the parallel structuring, the idea that the corresponding parts match up. So let's go ahead and just solve that out. If AB equals 15, 7A plus 2B equals C. And last but not least, the question tells us that A plus B equals 8. There's a couple of ways to do this. You could kind of look at the first one and the third one and say to yourself, well, I have two numbers that multiply to 15 and they add to 8. So the numbers are going to be 5 and 3 or 3 and 5. But, you know, we want to kind of plan for the worst. So let's say we're in an SAT and we don't realize that we can do that. We can also substitute one into the other. So here I could divide by B on both sides, and A equals 15 over B, and plug that in right here. And now we have kind of a complicated thing to solve. We can multiply by B on both sides. 15 plus B squared equals 8B. And that's a quadratic. We can take the 8B away from both sides. B squared minus 8B plus 15 equals 0. And now we're in a BC factoring situation. We're looking for two numbers that add to -8 and multiply to 15. And those numbers are -5 and -3. And now we have the zero product rule, which says that if each of these multiply together to 0, so B minus 5 times B minus 3 equals 0, then the zero product rule says we can set each one equal to 0. And when we solve each of those expressions, we get the 5 and the 3. So you either kind of visually see that the numbers that would have to work here are 5 and 3, or you go through a substitution and a quadratic process to get the 5 and the 3. So B can be 5 or it can be 3. If B is 5 and A plus B is 8, then that would mean that A is 3. And if B is 3 and A plus B is 8, that means that A is 5. So we have two pairs of numbers. A is 5 and B is 3, or A is 3 and B is 5. So with those pairs of numbers, we're looking for two values of C, and 7A plus 2B equals C. So if I start with 3 and 5, 7 times 3 plus 2 times 5 equals C. 21 plus 10 equals C, which is 31. And going to the other combination, 7 times 5 plus 2 times 3 equals C. So that's going to be 35 plus 6, which is 41. So our two answers we got are 31 and 41, which gives us D for dog on number 15. Now we're going to number 16. This thing right here, you want to ignore it most of the time, but it also kind of means if you get two answers, we know we're supposed to pick the positive one. But the confusing thing is that we're getting the information from the end of the question all the way at the beginning. So let's go ahead and just start solving this kind of the way we instinctively would here. Add 4 to both sides. T squared equals 4. Now you can take the square root of both sides, And for a square root, you have a plus and minus option. So the answer for the square root of 4 is plus and minus 2. And now it makes sense that we were told that t is greater than 0 because we know we need to pick the positive one. So positive 2 is our answer for number 16. Coming over to number 17. Let's see here. We've got, just going through the information, AB was said to be 1,800 feet. EB is said to be 700 feet. And BD is said to be 800 feet. And the length X that we're looking for is this one right here. So in terms of what we know so far, we know for a fact that these two angles are congruent. They're equal in measure to each other because these are vertical angles. So when you have opposite sides of like an X shape, like this X right here, then you have vertical angles. We're also told that these two angles, angles CDB and AEB, are congruent to each other. So far we've got some critical information here. Two triangles can be similar if two pairs of angles are congruent. That's called angle-angle similarity. So I got the two purple angles and the two orange angles. Therefore, the two blue angles have to be congruent. Because for instance, if the two purple ones are 100 and the two orange ones are 10, then we have 110 degrees of both triangles accounted for, and a triangle has to be 180. So the two blue ones would have to be 70, for instance, right? So if two pairs match, then third pair will also match. That's called angle-angle similarity. And what is similarity? Similar means that they are the same shape and different sizes, which for our purposes means that the corresponding side lengths all have the same proportions as one another. They're proportional. So which parts correspond is kind of the important part of this question. When we're dealing with the 1800, in terms of the color coding that we use, 1800 is the side that goes from blue to orange. So we'll kind of match up the two that go from blue to orange. And 700 is the side that goes from orange to purple. And X is the side that goes from blue to purple. So the two sides that go from blue to orange on both triangles are 1800 on the triangle on the left, and in the triangle on the right, we have an unknown. So I'll just put a question mark right there. The sides that go from orange to purple on the left triangle are 700, and on the right triangle are 800. And the sides that go from blue to purple on the left triangle are X, and on the right triangle is a question mark. So why is this extra hard for me? Is that CD is 1400. So that's going to give us just one extra one that was, actually, wait, CD. Let me just fill in these side lengths again to make sure that I didn't have an issue when I was first filling them out. So the question says AB, EB, BD, and CD are 1800, 1400, 700, and 800. So let me go ahead and fill those in again. AB is 1800. EB is 1400. BD is 700. And CD is 800. So a little bit better. And we can fill them in again. So blue to orange, left triangle, 1800. Blue to orange, right triangle, still question mark. Orange to purple, left triangle, 1400. Orange to purple, right triangle, 700. Blue to purple, left triangle, X, blue to purple, right triangle, 800. Much better. So the idea of a chart for proportionality or similarity is the idea that wherever you can draw a rectangle, you can draw a proportion. So we're able to now say 1400 over X equals 700 over 800. And now we can cross multiply and solve. 1400 times 800 equals 700 times X. Maybe right at this stage, divide both sides by 100, and that'll remove 2 zeros. So now we have 800 times 14. And that gives us 11,200 equals 7x. And now we're dividing both sides by 7. So we have 11,200 divided by 7. So 1 7 here, subtract, and you get a 4. 42 is 6. 7 times 6 is 42. And we have zeros left. So the answer for X is that it's 1600. And what is the value of X? 1600 for question number 17. Very confusing. And, we know that we're not going to be perfect on this, and you're not going to be perfect either. So sometimes we'll make a mistake. We'll go ahead and we'll put it back together and we'll get there. For the purpose of being effective with timing, when you see a question taking a long time, like us doing number 17 here, in a real live test, you might want to knock out all the quicker questions first before knocking out a question that's going to sort of steal away a lot of your time. Because they're not just trying to arrange this to make you get it wrong, they're also trying to arrange it to make you waste your time. So here, if we're solving for X, that might mean, to someone who's effective at doing this a little more quickly, that might mean to just get rid of Y. Just think about it. If I solve for Y and plug it back in for X, that's 2 steps. But if I just go ahead and solve for X from the beginning, get rid of Y, it's 1 step. So we could have multiplied these both by, or the top equation by -1, and you'd get negative X and positive X, and that's okay. But to get rid of Y off the bat, we're going to want to go ahead and multiply by -2. So we'll have -2Y and +2Y right there. So -2, multiplying everything by -2 on the top, -2x minus 2y equals +18. And on the bottom, x plus 2y equals -25. So now we have what we want. We have -2y and +2y. So -2x plus x is -x. And 18 minus 25 is -7, and x equals 7. And like we said, we're done on number 18 with as minimal work as possible. Going to number 19. Number 19 is a really important concept, which is the idea that cofunctions of complementary angles are equal. So cofunctions of complementary angles are equal. It's a perfect SAT concept because it seems like something really, really complex. Like when I deal with this with a student, I'll often get a little statement from the student about, I don't know a lot of trigonometry, I haven't taken pre-calculus yet. And it's kind of tricking us into sort of feeling like that, like I'm not good enough for this question. But it's much easier than it seems. It's the idea that there's a checklist. Do we have cofunctions? Well, sine and cosine are cofunctions. So yes, we do. Cofunctions would be sine and cosine, tan and cotan, or secant and cosecant. But on the SAT, we've only seen sine and cosine so far. Complementary angles are angles that add up to 90. So x and 90 minus x adds up to 90. So just to prove that, I could say x plus 90 minus x. And you can see when we lay it out like that the x's are canceling each other, leaving you a 90. So we have cofunctions in orange, we have complementary angles in blue. And the rule says cofunctions of complementary angles are equal. So we've just determined by this rule that the sine of x needs to equal the cosine of y. And so if this equals 4/5, then this whole thing here has to equal 4/5. And the answer is 4/5. So although there's a good amount of writing on the screen, if you're someone who knows this concept, you could just get the answer without doing any work, any real calculation or anything like that. And so by our definition, this is a great question. So going over to number 20 now, a is 5√2, 2a is root 2x. So let's start with the bigger one so we can substitute in a. 2a equals root 2x. I left the a blank because what we want to do is we know that a is 5 radical 2, so we want to substitute it right in there. So you have to be a little decent with radical operations. For instance, a root b times c root d is equal to ab root cd. And also, root b times root b would just be b. So when it comes to the radicals, if you have different things underneath, you're essentially multiplying and leaving the radical. But when you have the same thing underneath, this would really be the square root of b squared, and they cancel. So you have to kind of know by heart that that makes the radical disappear. So we're talking about some basic radical operations that you want to be good at. So in our case, we have the two numbers on the outside. So similar to how when we had a here and c there. Not my best podcast ever here because I'm seeing that these are reversed. That would have been AC root BD. So for those who are confused, apologies. The idea is that you're multiplying the two that are on the outside and you're multiplying the two that are on the inside. So there's our correction. But in ours, we have a 2 that's outside of a radical and a 5 that's outside of a radical. So that gives us 10, and the radical 2 just comes along. Now that we have it a little cleaned up, we can square both sides. So square the 10, you get 100. Square the root 2, you get 2. Square the 2x, the radical 2x, and you simply get 2x. So the radical, the squaring of it undoes the radical. So now we have 200 equals 2x divided by 2, and x equals 100. And that's it for College Boards. Practice Test 1, Section 3 solutions. Feel free to let us know if these are helping you. And if you need to start tutoring for the SAT or ACT, reach out to us. We'd be more than happy to help you. Have a wonderful day.